If you haven't done so yet, please pause the video and attempt to solve the question on your own before listening on. Because the track is frictionless, we know that energy is going to be conserved as the block moves from point A to point B. So we can set up the conservation of energy formula. So on the left side of this equation, we have the kinetic energy present at point B, as well as the gravitational potential energy present at point B. And then on the right side, we have the corresponding energies for point A. Now the block is released from rest, so that means that the initial velocity at point A is 0, which will eliminate this term right here. So we can simplify the equation. We will also notice that the mass appears in all three terms of the equation, so it can divide out. We could then solve for the speed of the block at point B by subtracting this gyb term from both sides of the equation. We could then multiply both sides of the equation by 2 so that we can cancel out the 1/2 on the left side. And then finally we can take the square root of both sides, and that way we can isolate the term VB on the left side. And then at this point we can plug in the known values for G, which is 9.8, Y sub A, which is the height at point A of 5 meters, and Y sub B, which is the height of 3.2 meters. And when we simplify the right-hand side, we could see that the speed at point B will be 5.94 meters per second. Now, a similar solution will apply when trying to calculate the speed at point C. The only difference is that we're going to change the subscript of B to C. So we won't rederive the formula. All we have to do is come in here and change this YB to YC, and that will lead to the same type of result. And with that change, we'll just have to change the height from 3.2 to the height at point C, which was 2 meters. And so when we compute that speed at point C, we get approximately 7.67 meters per second, and that is indeed the correct answer. We can next move on to part B of the question and calculate the work done by gravity as the block moves from point A to point C. Now, there are many ways to calculate the work done by gravity as the block slides from A to C, but one way is to use the work kinetic energy theorem, where we have the work done by the force equal to the change in the kinetic energy. Now, kinetic energy is 1/2 times mass times speed squared. The initial speed of the block at point A was 0, so that's actually going to knock out this term right here. And so all we have to do is plug in the mass and the speed of the block at point C, which we just figured out. And when we calculate that, we get 147 joules for the work done by gravity as the block moves from point A to point C. Thanks for taking the time to watch the video. If you liked it, please subscribe to the channel so you could stay tuned for additional videos. Also, you are welcome to send in your own question to the email address shown on the screen, and I will do my best to post a video solution to it on YouTube.